Why, hello there, lovely ones. So we are busy going through questions that involve trigonometry. These questions have been taken from the IEB Paper 2, November 2017. So this question is a very typical question, and you're guaranteed to get one in any kind of final exam, where you've got to write certain ratios in terms of a variable, and the variable is usually k. So we can see over here that they've included compound angles and they've made it equal to k, and then they've got some things happening down here. Before we can do anything, we first need to change this to be just one ratio, and that means we're going to use the compound angle identities. It's important that you have a good knowledge of the compound identities so that you can recognize them. This one over here has both a sine on and a cos on either side of the plus sign, which tells me that it's going to be a sine, the sine compound identity. And then we'll see with the different numbers or sizes of angles, they also rotate. It was 31 over there, it's now 31 over there. The other thing that we need to note is the plus that's over there. Your compound identities are given to you on a formula sheet, and they look like this. They're sine alpha times by cos beta or beta, or however you say it, and then next to it it's going to say cos of alpha times by sine of beta, and that's of course equals to sine of alpha plus beta. So that's how I know that this over here is going to also equal sine of 31 plus 22 degrees. And that's important because then we see that that is the same as sine of 53 degrees, which is actually our very first question. So let's write this out neatly. So as you can see, this leads to a very nice place where we can make it equal to k. And the whole question is really testing, can we recognize and then as a result use compound identities? Now this over here is going to help us with the next questions. Whenever you see an angle that is more than 90 degrees, you know you're going to have to change it to its acute angle form. So before I actually get to anything else with the second question, I'm going to reduce it. So it was cos 143 degrees. I'm going to say that that's the same as cos of 180 degrees, and it's minus 37 degrees, which, let me just scroll a little bit, which will give me, it's in the second quadrant, so it's negative cos, helps if I can spell, negative cos 37 degrees. And let's scroll a little bit more. So we know that we had sine of 53 degrees is equals to k. At the moment, the 37 degrees, or cos of 37 degrees, isn't helping us, but we do know that sine of theta is the same as cos of 90 minus theta. So that means that we can change this to be sine of 53 degrees. So I know that because these two numbers, let me just put some green in, these two numbers are complementary. When I add them together, 37 degrees plus 53 degrees, I am going to get 90 degrees. That's how I tell. Okay, and of course we know that sine of 53 degrees has the same value as k, so that means we have negative k over here. There is one thing I want to talk about. It is possible to go straight from cos of 143 degrees to negative sine of 53 degrees by doing 90 plus. But sometimes it can get a little confusing in an exam situation, so I would recommend that you always first reduce the angle and then after that change to its co-ratio. In terms of what this particular question is testing, it is actually testing can we change from or between co-ratios. So far we have tested compound angles, and now we're looking at co-ratios, and let's look at what the last question asks. And I've been sneaky and I've just copied and pasted the question over here. If we take a look at it, we've got two sines with different angles adding to two coses, also both with different angles. And once again, you've got to start thinking about compound angles. And the reason I know it's compound angles is because of the way it's structured. It is fine to go and double check what those identities are, but you should try and know as much of it as possible. For example, I know that this is going to be cos of something. The reason I know that is because I've got the two sines on the one side and I've got the two coses on the other side. I also know that it's going to be a minus because with the cos one, it's the opposite. So it's going to be cos of 75 degrees minus 22 degrees, which of course gives me cos of, you guessed it, 53 degrees. And the reason why this is problematic is because we know what sine of 53 degrees is. Because of 53 degrees, we can't change to sine. However, you have the skill that you actually learned back in grade 10, which is probably why we forget about it most of the time. And that is, we can draw it on the Cartesian plane. It's not the greatest drawing, please excuse it, but anyway. Let's say this is 53 degrees, and according to the other stuff, sine is opposite, so that's k over 1, which means that this other side is going to be 1 minus k squared. And the reason that is what it is because of Pythagoras. So we know that that's what it is, and we just plug that in over here, that cos of 53 degrees is the same as 1 minus k squared. And that, my dear, is the end of that question. Much love.